Let's talk about triangles in Introduction to Engineering. Before we do that, let's take a look at parallelograms. Parallelogram has two sets of parallel sides, and it can be a rectangle, but it also can be skewed. To find the area of a parallelogram, you take the base, which is the length of the side at the bottom, and multiply that times the height, which is from the highest point to the same plane as the bottom, or the same axis as the bottom. So if you multiply those two together, you get the area. Be sure and pay attention to your units. If it's meters for the base and height, then you have a result in square meters. Let's talk about triangles a little bit. There are three triangles that we're concerned with. The right triangle, which has one angle that is equal to 90 degrees. An obtuse triangle, which has one angle that is greater than 90 degrees. And the acute triangle, in which all angles are less than 90 degrees. When you consider the parallelogram, we found the area by multiplying the base and height. If you draw a line from one corner to the other, you can see that you end up with two triangles. So to find the area of a triangle using this same idea, it's just 1/2 of that area. So the area of a triangle, the formula is going to be A equals 1/2 base times height, or base times height over 2. Both are mathematically the same. When you have a right triangle, we can label the sides A, B, and C. C is normally reserved as the hypotenuse, which is the longest side of any right triangle, and it's always opposite of the 90-degree angle. And we can use Pythagorean theorem to find the length of any side if we know the other two. So in this case, the hypotenuse squared is equal to a squared plus b squared. A couple of terms to be familiar with. If you take a triangle and draw a circle around it, connecting the tips of the triangle to the circle, this is known as inscribed. Think about it's inside the circle. Inscribed is inside the circle. And if you put the circle inside, it's circumscribed. And in this case, you would have your triangle, and the circle would contact all of the sides. And this is just hand-drawn, so it's not very good. But you need to know what the term circumscribed means and the term inscribed means. And when we think about triangles, the reason we like them is they are structurally very strong. It's very hard to cause them to deform by applying forces at any of the connection points. And that's all we have on triangles.